Assalamualaikum warahmatullahi wabarakatuh. My name is Azman bin Mohd Rashid from UTM Space Kuala Lumpur. So my metric number is SX210213 EMMHS04. Alright, today I'm going to present about thermal properties of polymer. The subtopic of the presentation is about glass transition temperature and melting point. Okay, for the first slide, what is the glass transition point? Amorphous polymer exhibit the glass transition temperature phenomena. The glassy stage of the polymer changes to the rubbery stage at this temperature. Transition glass is a crucial component of polymer behavior. It's designed a zone where the mechanical and physical qualities undergo significant changes. Glass transition temperature varies from 140 degrees Celsius to 370 degrees Celsius according to the grade used. For a specified grade, the glassy transition temperature rises from 50 degrees Celsius during post-cure. This depends on the method and the moisture content. Right, from this sentence, how we want to know the transition glass will be, the process will starting. Alright, for the first point, when we see the glassy stage change to the rubbery stage. And the second point is the mechanical and physical changes. So from 2 points, we know this is the process of the transition glass. Right, the unit used for the measuring glass transition temperature have three. Number one is degree Celsius, number two is degree Fahrenheit, number three is Kelvin. So from three unit, we can use either one for measuring the glass transition temperature. The next is the temperature of the polymer shift from the glassy to the rubbery stage is known as the glass transition temperature. So this is the point that I said before, the important point that how we want to know the process of the transition glass. Alright. Next is as opposed to the rubbery stage, which soft and flexible due to long range rotation of polymer chain segment. So the glassy stage is a hard and a brittle stage of material made up of the short-range vibration and rotation motion of atoms in the polymer chain. So we can see the picture from the slide. We can know how the glass state example and how the rubbery stage example. Okay, some polymers are used above their glass transition temperature and some are used below the glass transition temperature. Okay, hard plastic that are in their glass stage, such as polymers and polymethyl methacrylate, are employed when the temperature is below their glass transition point. They have transition glasses that are much warmer than ambient. Polystropine and polyisobutylene are two examples of elastomers that are utilized above their transition glass temperature, where they are soft and flexible. Okay, from the picture, we can see this is the example of graph for the polymer transition glass. Okay, from the graph, we can see this is the modulus against temperature. Okay, below the glass transition temperature, the polymer are hard and brittle like glass. It is because of due lack of mobility. Okay, above the transition glass, the polymer are soft and flexible like rubber, and also above the transition glass, the physical and mechanical properties of polymer will be changed. This is because of due to some mobility. Okay, next, let's see to the graph. Okay, from the graph, we can see they have a three stage of the transition glass process. So number one, from the curve A, that's represent as the glass stage. Second one is we call a curve B, that represent a semi-crystalline solid. And from the point at the curve C, that represent of the crystalline solid. Okay, we go to the next table. Okay, from the table, there is the examples of the material that used to the transition process. Okay, from the example, we have such as polyethylene low density, we have polyethylene high density, we have polypropylene, we have nylon, and we have polystyrene, we have polycarbonate, and so on. Okay, from the table also, we can know the glass transition temperature and also the melting transition point temperature. Okay, for example, let's see the polyethylene low density. The glass transition temperature is about negative 110 and the melting temperature is about 115 derajat Celsius. Okay, for the next example is nylon 66. The glass transition temperature is 57 and melting temperature is 265 and so on. Alright, some polymers such as polystyrene and polymethyl methacrylate are utilized below their glass transition temperature. Okay, some polymers such as a rubber elastomer like polyisobutylene and polyisopropene are employed above their transition glass in the rubbery stage. Okay, this is the three stage of the polymer that I said before. First is amorphous polymer, second is crystalline polymer, and third is a half crystalline polymer or semi-crystalline polymer. So from the picture, this is the example of the glass transition temperature for the amorphous and semi-crystalline. Okay, let's see number one. Number one is amorphous polymers. Okay, amorphous polymer have a random molecular structure. At transition glass, they take the glassy stage properties like brittleness, stiffness, and rigidity upon cooling. They have a lower transition glass than semi-crystalline polymers. This is because their polymeric chains are physically entangled and have spaces between them or at the chain's end. This space is known as free volume, which have polymer chains to move at lower temperatures. Higher the volume, lower the glass transition temperature. Okay, number two is crystalline polymers. Okay, crystalline polymers have a molecular structure that is very well arrangement. They have a clear and limited melting point. Rather than melting as the temperature rises, this melting temperature is typically higher than the range of thermoplastic that are amorphous. The crystalline polymer polyphenes PEEK, PET, and POM are the example. Okay, this is the number three is half crystalline polymer or semi-crystalline polymer. Okay, semi-crystalline polymer mix of randoms and structure elements. Higher transition glass is produced as a result of this structure, which are crystals that prevent polymer chain from moving freely. Okay, next, let's see the factor affecting the glass transition temperature. Okay, the factor that affecting the glass transition temperature is the flexibility and mobility of the polymeric chains. The ease with the chain segment can rotate along the backbone chain determines the glass transition temperature. The glassy stage can be changing into the rubbery stage at the lower temperature if the polymeric chains can move above rigidly. That is, the glass transition temperature is lower. The glassy stage is more stable if the chain's mobility is constrained in some way, and it is challenging to remove the constraint that keep the chains immobile at lower temperature because doing this require more energy. Okay, from the slide, they have a 6 factor that affecting glass transition temperature. Okay, the factor number one is about the change flexibility. Number two is about intermolecular interactions. Number three is about the molecular weight. Number three is about the copolymerization. Number five is about the cross-linking. Number six is about a plasticizer. So from six factor, all the factor have a different characteristic. Okay, let's see the factor number one. Okay, the factor number one is molecular weight transition glass. Molecular weight transition glass is directly proportional to the molecular weight of the polymer. Short chains have more free volume transition glass for the short change will be lower than transition glass for the lower change. Alright, number 2 is cross-link transition glass. Cross-link transition glass is directly proportional to the degree of the cross-link. So from the picture, that's an example of the cross-link arrangement molecular. Okay, number 3 is a plasticizer transition glass. Plasticizer transition glass is inversely proportional to the plasticization. Weakened intermolecular force between the polymer change will be reduced the transition glass. Okay, flexibility transition glass is the inversely proportional to the flexibility. Okay, from the flexibility example, we can see they have a two example the example change that occur for the flexibility transition glass. For number 1, we have a polyethylene adipate with the transition glass temperature negative 70 degrees Celsius. And example number 2, we have a polyethylene terephthalate. We have a transition glass 69 degrees Celsius. So presence of the penyl group in the change backbone is increased rigidly and transition glass. The next factor that affecting the transition glass is intermolecular force transition glass. So intermolecular force is directly proportional to the intermolecular force. Okay, from this example, we can see also the change arrangement of the intermolecular force. Okay, we have a number 1 is atactic polypropylene with a transition glass temperature negative 20 degrees Celsius, and we have example number 2 is atactic polyvinyl chloride with the transition glass temperature 81 degrees Celsius. Okay, last factor is change branching. Polymers with more branching have more change end, so have more free volume, which reduce the transition glass. But the branches also hinder rotation like large side groups, which increase the transition glass. From the change branching, we also have a two example. For number 1 is atactic polypropylene. The transition glass is about negative 20 degrees Celsius, but the aesthetic polystyrene is different with intermolecular force. So the transition glass temperature is 100 degrees Celsius. Okay, it's possible to alter transition glass of polymers when considering polymer for particular end use. Okay, next we go to the melting and glass transition temperature. Okay, regarding in the service use of the polymers, melting and glass transition temperature are significant factors. For many applications, those involving semi-crystalline polymers, they are regarded as the upper and lower temperature limitations respectively. The upper use temperature for glassy amorphous material may also be defined by the glass transition temperature. Additionally, transition melting and transition glass have an impact on how polymers and polymeric metric composite are made and processed. When the transition melt is applied to the polymers, it suggests a transition from a crystalline phase to a solid amorphous phase instead of the solid liquid phase transition. Only thermoplastic are considered when talking about crystalline melting because the thermoset will be broken down at high temperature rather than melt. Okay, from the slide, this is the examples of the change length of nylon for the melting point. So from this, we have a nylon is used to the melting point. Okay, we have a lot of type such as we have a nylon 3, nylon 4, nylon 5 is also from this example we have the temperature of the transition melt for the nylon. For example, for the nylon 3 we have a 330 degrees Celsius. So nylon 4 we have 270 degrees Celsius. Nylon 6 we have 230 degrees Celsius. and so on. Alright. From this also we have a general polyester structure. So we can see the melting of the polyester, such as PET. We can see the change of the PET. We can see also the point of transition temperature. For the PPT, we have 228, we have PBT 225, and so on. All right, this is the graph that show the positions of the melting point. So number one, we can see from the graph, we can see they have a glass transition temperature 79 degrees Celsius and go to the crystalline 159 degrees Celsius, and the melting point will be occur when the degree is 348 degrees Celsius. Alright, so the higher temperature will destroy the molecular arrangement. So when the temperature will become the higher, the molecular arrangement is easy to destroy. Alright, number two is small crystal will melt fast ever. So when we use the crystal, the small crystal, so the melting time will be fast. And for in keeping crystal size, so sharp melting is occur. The next is a crystalline melting point temperature. Okay, if the temperature rises further, the molecule will be given more energy and the rubbery will be melt. For the sake of simplicity, let's assume that the host is composed of thermoplastic, non-cross-linked material. The melt phase is now. The melt temperature, often known as the thermal transition melt, is the temperature at which molecule change from the rubbery stage to the melt stage. So from the slide, we can see that's the example of the crystalline melting point graph show. Okay, for the last but not least, let's see the factor of affecting transition melt. Okay, they have a three factor that will be affect the transition melting. Okay, factor number one is the same element influence transition glass and transition melt. Its height transition glass and height melting point are typically discovered together and vice versa. Okay, factor number two is high polarity and hydrogen bonding will increase the melting point or transition melt. And the last factor is the high transition melt or high melting point result from molecular symmetry. For example, a dot transition glass is low due to the change flexibility. For example, its polystyrene has a high transition melt because of its densely packed is crystal. Okay, that's all for me. Thank you for your time for hearing my presentation. So I hope my topic will give a bit of knowledge to about transition glass and melting point for you all. So thank you for your time. Assalamualaikum warahmatullahi wabarakatuh.